Hey, your favorite MP here. Who is excited about learning some algebra today? I am. Today we're going to talk about equality and identity properties. So there's going to be two things we learn today. One, we're going to be able to recognize equality and identity properties, and then we're going to be able to utilize those properties. So let's go ahead and dive on in here. All right. Let's pretend that there are these 5 race car drivers. And we're going to pick some NASCAR people. Anybody like NASCAR? Well, if you don't like NASCAR, just hang in there. Alright, let's say we have Kyle Larson. And we have another Kyle Busch. And we have Joey Logano. And let's throw in the fan fave right now, Chase Elliott. And let's say Ross Chad. Okay, so let's say that at the first race, they were at Daytona. And the second race was California. And we want to know their final ranking after these first 2 races. So let's say for the first race, Kyle Larson was ranked first. And let's say Kyle Busch was ranked third. Joe Logano was ranked 5th. Chase Elliott was ranked 4th. Ross Chastain was ranked 2nd. Then at California, let's say that Kyle Larson ranked 1st in that race also. And Kyle Busch ranked 2nd in that race. And Joe Logano ranked 5th. Chase Elliott, he ranked 3rd. And Ross Chastain ranked 4th. And let's say that their final rankings after those first 2 races, Kyle Larson's 1st, Kyle Busch is 2nd, Joey's in 5th, Chase is 3rd, and Ross is 4th. So let's take a look at Joey. Alright, so he started off 5th in ranking. And maybe we don't know what he ranked in California, and his final rank was 5th. Well, the number to add here, x would be 0. So x 0 plus 5 is 5. And that follows the additive identity for the sum of any number is equal to the same number if it's added to 0. Thus 0 is the additive identity here. Okay? Let's take a look at some other things. All right. Let's say that we have 7 times y. And that is going to be equal to 7. So here we know that y is equal to 1. And this is called the multiplicative identity. And I don't know if you remember from the previous videos when we were learning other topics, anytime you multiply 1 by itself, it looks like itself, it is itself. So this is the multiplicative identity. Now let's look at another identity. 12 times z, or z, is equal to 0. So in this case, what is multiplied by 12 to equal 0? It can only be one thing. Z has to be equal to 0. Anytime you multiply 0 by another number, it becomes 0. And this is called the multiplicative property of 0. Let's look at another one. Let's say that we have 7 over 40 times 40 over 7. This is equal to 1. Because 7 times 40 is 280. 40 times 7 is 280. 280 over 280 is 1. This is called the multiplicative inverse Some people call this a reciprocal. Okay, so let's try to name some properties. I'm going to give you an example and you tell me what you think the identity property is. So let's try 7 times A is equal to 7. So let's think here. So 7's on the left-hand side and 7's on the right-hand side. So therefore A must be 1. So if A is 1, this is the multiplicative identity property. Alright, let's try another one. B plus 0 is equal to 12. Alright, so anything plus 0 is going to be equal to itself again, right? Right. So this is the additive identity property. You're doing great. Let's look at one last example here. Let's say we have C times 40 is equal to 1. So how do we get to 1? Well, we have to multiply it by its reciprocal. The reciprocal of 40 is the same as 40 over 1. The reciprocal would be 1 over 40, right? So this is the multiplicative inverse property. Great job. All right, let's keep moving on. Let's talk about properties of equality. And let's look at some. So let's say, let's change colors here. We have 40 is equal to 40. Which one is this? This would be the reflexive property. Okay, let's take a look at another one. 7, oof, that's not a 7. 7 is equal to 3 plus 4. We could also rewrite this, say 3 plus 4 is equal to 7. That's still a true statement. Therefore, this is the symmetric property, because you can write it either way and it's still true. Let's take a look at another one. We have 7 plus 12 is equal to 10 plus 9. So 7 plus 12 is equal to 19. 10 plus 9 is equal to 19. So this is the transitive. Let's look at one last one here. Let's say we have 3 times x is equal to 21. So we know that x is equal to 7. So 3 times 7 is equal to 21. This is called the substitution property, because we substituted 7 in for x. Okay, let's do a little example using these, and I want you to name each property for each step that we solve. So we want to evaluate 3 times 1 times 7 minus 6 plus 40 times 1 over 40. Alright, so we can evaluate this. All right, so let's say 3 times 7 minus 6 plus 40 times 1 over 40. What rule happened here in the red? There are actually two rules that happen. One was substitution, and the other one was multiplicative. All right, let's solve the rest of this. Let's keep going here. So let's say 3 times 1 plus 40 times 1 over 40. All right, so what happened here in step in blue? This was the substitution property. All right, let's keep solving here. All right, so we got 3 plus 40 times 1 over 40. All right, what rule did we do here? This was the multiplicative. Good job. All right, so now we got 3 plus 1. What rule did we do here? This is the multiplicative inverse. All right. So then our final answer is 4. And this is using substitution. So let's go back and look at this. All right, in this case, we're substituting 1 times 7 as 7. So we plug that into here. Oh. Okay. All right, and then we did a substitution here. And what did we substitute? 7 minus 6 is equal to 1, so we substitute 1 in place of that. All right, what did we do here for the multiplicative? We did 3 times 1 is 3. And here, what did we do? Well, we did 40 times 1 over 40 is equal to 1. And then what substitution did we do here? 3 plus 1 is equal to 4. So we plugged in 4. All right. I appreciate your time. This is MP.